Hi, I'm Hw5q1. Now I'm doing the video explanation for question 1 of homework 5. We know that x and y are independent with density function like this, and fy the density function of y, probability density function is this, and they equals to x plus y. We need to find the probability density function of z. In first part, we need to use convolution methods. The second part, we need to use geometric methods. Let's do the first part, which is convolution method. First, we can calculate probability density function of z for z equals to x plus y. Then fx probability density function of x equals to x minus x minus 1, and the probability density function of y is same as question. After that, we can just shift the result to right side by 1. We will get our result. Okay, sorry. Your side, we good. Fz equal to the probability density function of z equals to probability fxz star fyz, which is integral from negative infinite to infinite fx alpha fy z minus alpha d alpha. That's as shown here. We continue to do that. It's x minus x minus 1. Now it's alpha. Oops. Let's do it again. Alpha minus 1. Then we need 2 times z minus alpha minus z minus alpha minus 1, then the alpha. Then we need to calculate this equation. That's alpha, this part, and we can divide it into 4 parts. First part is alpha times z minus alpha d alpha. Then minus integral from negative infinite to infinite alpha times z minus alpha minus 1. Second part is the third part is minus alpha times z minus alpha. Here is alpha minus 1, and the alpha. The last part is we need to plus integral from negative infinite to infinite alpha minus 1 times z minus alpha minus 1. Oh, here is d alpha. So that the first part will become from 0 to integral from 0 to z alpha times z minus alpha d alpha and times z. The second part is similar that from 0 to z minus 1, then alpha z minus 1 minus alpha d alpha then times z minus 1. The third part is same as the first two parts. Is from 1 to z and times alpha minus 1 z minus alpha d alpha and times z minus 1. The last part is from 1 to z minus 1 alpha minus 1 z minus 1 minus alpha and time d alpha times z minus 2. Which is from 0 to z times 1 d alpha times z minus from z to 0 to z minus 1 times 1 d alpha z minus 1, then minus from 1 to z times 1 d alpha times z minus 1. The last part is we need to add from 1 to z minus 1 d alpha z minus 2. Finally, we get our result is z times z minus z minus 1 times z minus 1 minus z minus 1 times z minus 1 and plus z minus 2 z minus 2. We should notice that this result is not the final result. It's a probability density function of z for f(x) equals ux minus 1. We need one more step to shift it to right by 1 to get our final results. So for z equals x plus y, where f(x) is x plus 1 minus x minus 2 let's see. Fy is Uy minus Uy minus 1. We can get our answer is probability density function of z equals z minus 1 u minus 1 just minus 1 for all the 4 parts, minus 2 u z minus 2 z minus 2 u minus 2, the last part is minus 3. Okay, that's our results. The second part is use another method. Yeah, like the first part, we calculate density function of the for z equal to x plus y, x equal to x minus 1, and the density function of y equals to y minus 1, and to get our result, we just need to shift the result to the right by 1. Now we get the probability distribution function of z equal to probability that all z is less than or equal to z, which is xy, probability of x plus y is less than or equal to z. The first condition is when z is less than or equal to 1, we can draw the plot it. This is x, y, and here is 0. It's 1, 1. Assume here is z. Z is less than or equal to 1, and this line is x plus y equal to z, and this area will be x plus y is less than or equal to z. Now we can calculate distribution function of z is this area, which is this squares over 2. Now we can get probability density function of z is equals to the distribution function of z by dz, which is z. Let's see, the second condition is when z is larger than 1 but less than or equal to 2. And same, we need to draw draw the picture again. X, Y, Z, and here is 1, Y equals to 1, X equals to 1. So here is Z, and we need to calculate this area. It's very easy. We calculate distribution, probability distribution function of Z is probability that X plus Y is less than or equal to Z, which is a large triangle area, which is Z squares divided by 2, and minus 2 little triangle area, which is Z minus which is Z minus 1 squared and then divided by 2. The result is negative Z squared divided by 2, then plus 2Z then minus 1. We can get probability density function of Z is negative Z plus 2. The last condition is when Z is larger than 2. The area will be 1 times 1, which is 1, so that probability density function of Z is 0. Therefore, we get Fz and the probability density function of Z in the first when Z is less than or equal to 1, Fz equal to Z is this part, and the second part is Z minus Z plus 2 is this part, and when Z is larger than 2, the function will be 0. To get our final result, we need to shift the picture to right by 1. It like this: 1, 2, 3, 0, Z, F, Z, Z. Now we get probability density function of Z equal to Z minus 1 times Z minus 1 and minus 2 times Z minus 2 times U Z minus 2, then plus Z minus 3 times U Z minus 3. Okay, that's the solution of the first question of Hw5.